Hey guys, welcome to this session by Intellipaat. Amazon Redshift is a cloud data warehousing tool which is available in AWS and it is the fastest cloud data warehousing tool available. Companies like Lyft, SoundCloud and Philips are few among the thousands of companies who use Redshift for their data warehousing needs. And it is very easy to get started with Redshift. And also guys, at the end of this session, you will be able to start with Redshift independently. And also, before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos. Now let us take a quick glance at the agenda. We'll start off with a quick introduction to Redshift and its use cases. After that, we'll look at Redshift's architecture and its components. Moving on, we'll look at the concepts of Redshift and its integration with other services. And finally, after learning all of these concepts, we'll do a hands-on on Redshift and understand it even better. Now, without any further delays, let us begin with this session.
Now let us see the data warehousing tool which is provided by AWS, that is Amazon Redshift. So Amazon Redshift is a fully managed petabyte scale data warehouse service in the cloud. So you can scale this particular service up to petabytes. So you can start with just a few hundred gigabytes of data and scale to a petabyte or more. This enables you to use your data to acquire new insights for your business and customers. So it provides you so much of storage. You can store a lot of data, and also it has a different kind of an architecture which I'll show you. Using that architecture, you can query results faster, and yeah, you can acquire new insights of your business and customers as soon as possible after the data is loaded. And yeah, so now Amazon Redshift service manages all the work of setting up, operating and scaling a data warehouse. It takes care of everything because that's what AWS does for us. And these tasks include provisioning capacity, monitoring, if we get metrics for almost every service, then backing up the cluster. We can back up using snapshots, automated backups, and applying patches and upgrades to the Amazon Redshift engine. Yeah, this is also AWS. They do this for us. And so 3 into faster than other cloud data warehouses. So they give us the confidence that this is 3 times faster than the other data houses available. And yeah, so performance matters, and Amazon Redshift is the fastest cloud data warehouse available. Redshift is the world's fastest cloud data warehouse and gets faster every year. For performance intensive workloads, you can use the new RA3 instances to get up to 3x the performance of any cloud data warehouse. So I think this was announced in the recent reInvent event of AWS. And also this Aqua Advanced Query Accelerator also was announced, and this will be available in 2022 2020, not now. So Aqua is a new distributed and hardware accelerated cache that allows Redshift to run up to 10 into faster than any other cloud data warehouse. So they have this system, they are building the system. I think it will be available in 2020, not right now. And also this Aqua system, when they build it, it will be compatible with the older Redshift versions also. Yeah, so yeah, this is the basic information. And then one more is that it is 50% less expensive than all other cloud data warehouses. This is another promise they make us. So Amazon Redshift costs less to operate than any other cloud data warehouse. Start small at $0.25 per hour and scale up to petabytes for under $1,000 per terabyte a year. Pay only for what you use. So that's exactly what every cloud service does. For us, we only pay for what we use and know how much you'll spend with predictable monthly costs. Amazon Redshift is at least 50% less expensive than all the other cloud data warehouse. They are telling at least, so it might be even lesser expensive. Scale and pay for storage compute separately and get the optimal amount of storage and compute for diverse workloads. So basically here you can, instead of choosing one instance which both covers the storage and compute, they give you options of selecting storage and compute separately. So you can provide according to your needs. Choose the size of your Redshift cluster based on the performance requirements and only pay for the storage that you use. The new managed storage automatically scales your data warehouse storage capacity without you having to add and pay for additional compute instances. So the new managed storage, so basically what they're saying is it automatically scales our data warehouse storage capacity for us. Yeah, so this is automatically done. We don't need to provision or we don't need to do anything. And yeah, so these are the use cases. These are the two use cases provided. The first one is business intelligence and the second one is operational analytics on business events. So first, business intelligence. Redshift makes it simple and cost effective to run high performance queries on petabytes of structured data so that you can build powerful reports and dashboards using your existing BI tools. As I told you, you can run high performance queries on petabytes of structured data, and you can use that data for creating reports, and you can connect it with your existing BI tools, and you can get insights out of it. And operational analytics on business events bring together structured data from your data warehouse and semi-structured data such as application logs from your S3 data lake to get real-time operational insights on your applications and systems. So they are telling we can combine both structured and semi-structured from two different services. One is the data warehouse service, one is the data lake service, and we can gather operational insights on our applications. Yep, so these are the two use cases, and this I wanted to show. That's it. This is nothing important. So these are few companies. Yeah, Amazon uses Redshift, and so what they have said is Amazon Redshift has been a key component of our successful migration of Oracle and has enabled us to significantly reduce the cost of our analytics while scaling to support one of the largest analytical workloads in the world. We all know Amazon, I think per minute $300,000 of transactions happen on Amazon. So a lot of products being bought. So yeah, it is a very huge workload for them. So for that, they're using Redshift and it's working well for them. And then coming to McDonald's, Amazon Redshift enables faster business insights and growth and provides an easy to manage infrastructure to support our data workloads. Redshift has given us, this is just something. They just talking something about Redshift. So these are few companies which use Redshift right now. Okay, so now we've come. Yeah, so that was just the introduction of Redshift. What is Redshift? It is a data warehousing tool provided by Amazon, and the few companies using it, and those are the use cases. You can use it for analytics, and you can use it for getting operational insights, and you can use it as the data provider for your BI tool. Yeah, so that's what we saw. Now let us look at the concepts of Amazon Redshift. So this is the architecture which they provide us, AWS providers. So this is the architecture of Amazon Redshift. So these are the client applications, and so here this is the data warehouse architecture of Redshift. So they have a leader node and they have multiple compute nodes. You can have multiple compute nodes, and all those compute nodes have node slices also. So I'll explain all of these concepts right now. So this is the basic structure, and they provide you two different connectivity options. One is JDBC, one is ODBC. This is for open connectivity and this is for Java connectivity, and you can use them to connect with your client applications. So this is the basic architecture of Redshift data warehouse. Now, so client applications in the sense, Amazon Redshift integrates with various data loading and ETL tools and BI tools. So you can see BI tools, reporting, data mining, and analytics tools. It integrates well with all of these tools, and it is based on an industry standard PostgreSQL. So basically, the entire Redshift structure is built on a PostgreSQL database. So that's what they have used. So most existing SQL client applications will work with only minimal changes. So I think you can use this with your MySQL Workbench or SQL Server or other clients. So I think they work with it. And also, yeah, so as it is built with PostgreSQL, you can also use the PostgreSQL client. So yeah, these are the client applications and connections. Amazon Redshift communicates with client applications by using industry standard JDBC and ODBC drivers. They provide both. You can use either of them. And clusters. So clusters, they are the core components. And so the leader node compiles code for individual elements of the execution plan and assigns the code to individual compute nodes. So for example, if a huge query, if a huge code comes in, so leader node takes it, it splits it up into a smaller workload, a smaller queries or smaller tasks, it provides it to the available compute nodes respectively, that the leader node decides how to provide it. So basically this concept is used so that the time it takes to query something reduces, and so you don't need to pay anything for the leader node, you just pay for the number of compute nodes you create. And yeah, a cluster is composed of one or more compute nodes. So basically this part is the cluster. It can have one or more compute nodes, and then yeah, if a cluster is provisioned with two or more compute nodes, an additional leader node coordinates the compute nodes and handles external communication. For example, if you have only one compute node, if you create it with just one compute node, there is no need of a leader node to distribute work among the other compute nodes, because there is only one node and all the work will be assigned to that. So there is no use of leader node. So but if you assign more than two compute nodes, then a leader node is automatically assigned, and all the incoming queries, all the incoming transactions are taken care of. Leader node takes care of it. It divides it into multiple smaller tasks and provide it to the compute nodes accordingly. And your client application interacts directly only with the leader node. The compute nodes are transparent to the external applications. So these client applications do not contact the compute nodes available. If you have two or more nodes, two or more compute nodes, then your client application's only point of connectivity is the leader node, not the compute nodes. So all the requests first go to the leader node, then it goes to the compute node. So that is what they are saying. And the next point, yeah, the leader node. Coming to the leader node and the compute nodes. So the leader node manages communications with client programs and all communication with compute nodes. Yeah, it takes care of all the communication between the client programs and the compute nodes. It stands in the middle. It's like a middleman, and it parses and develops execution plans to carry out database operations. So any kind of a huge database operation will be taken care of the leader node. The leader node will assign the work to the compute nodes accordingly. So yeah, especially the series of steps necessary to obtain results for complex queries. So if you hit in a complex query, it first goes to the leader node. Yeah, it is the first point of contact for any client application. So the leader node now splits it up accordingly. It splits it up in multiple parts and provides it to other compute nodes, which do their part and provide the results back, and the leader node aggregates them into a single result and sends it back to the client application. So this is why we need a leader node. Based on the execution plan, the leader node compiles code, distributes the compiled code to the compute nodes, and assigns a portion of the data to each compute node. So according to the execution plan, the leader node will compile the code, then distribute the compiled code to the compute nodes. So now coming to compute node part, so the leader node compiles code for individual elements of the execution plan. There might be a huge execution plan which is currently executing, and assigns the code to individual compute nodes. Yeah, so the compute nodes execute the compiled code and send intermediate results back to the leader node for final aggregation. So these code will be sent to the compute nodes. The compute nodes will run the queries. After running the queries, all that results will be sent back to the leader node, which will aggregate them, which will finally aggregate them and send it back to the client application. So each compute node has its own dedicated CPU, memory, attached disk storage, which are determined by the node type. So there are multiple node types also that we'll see while creating the Redshift cluster. So basically every compute node will have its own CPU, its own memory, its own disk storage attached to it. And Amazon Redshift provides two node types: dense storage nodes and dense compute nodes. Each node provides two storage choices. Okay, so basically these are different storage types. Basically, node type in the sense, in the previous sentence, instance classes, we saw instance classes, right? Like that, there are multiple node types also. Yeah, so they have different specifications that also we'll see. So there are two types of nodes here. One is dense storage nodes and one is dense compute nodes. So I think the dense compute nodes will have a lot of computing power, and the dense storage nodes is used for scaling up your storage whenever you need, or scaling down. Yeah, I think you cannot scale down. Yes, so scaling up your storage whenever you need it. So these are two different nodes which are entirely separate, and these are assigned separately. As I told you, these are separate, the compute and the storage, and the storage can be auto scaled accordingly. AWS does it for us, and same goes with compute, but you'll have to change the instance type accordingly. And a compute node is partitioned into slices. Each slice is allocated a part of the node's memory and disk space, where it processes a portion of the workload assigned to the node. So even the compute node has multiple node slices within it. So you can see this is the storage area. So all of these node slices has their own compute power, have their own storage area. So now this compute node will be provided with a simpler query. Now this compute node, it will split that query into multiple parts if it requires multiple parts, if it cannot handle the workload in just one node slice. So what it does, it separates it and provides it to multiple node slices. So these node slices are responsible for executing those queries or executing those operations. After they execute them, so the data obviously will be available in the storage area. It gets that back and sends it back to the leader node for final aggregation. So these are node slices. They are smaller parts of a compute node which have their own CPU. So they have their own memory and their disk space where they process a portion of the workload assigned to them. So the node slices will be assigned a portion of the workload which is assigned to the compute node, and they execute them. So these are compute nodes. Okay, now these are the basic concepts of the Redshift architecture. One is the connection, one is the cluster. Under cluster, there are leader nodes and compute nodes. A leader node is a single point of contact for the client applications. Then compute nodes, you can have a number of compute nodes. We'll see how much. So if you have two or more compute nodes, then a leader node is automatically created, and the leader node is responsible for splitting up huge workloads into smaller workloads and providing it to the compute nodes. And the compute nodes have their own subversions. Those are node slices, and these node slices have their own memory and storage space, and the workload assigned to the compute node will be split up into smaller workloads again. It is given to the node slices, they execute their part, give it back to the compute node, and the compute node gives it back to the leader node for final aggregation, and that finally collected result is sent back to the client application. So this is the architecture of Redshift. Now performance. So why does Redshift?
Sorry,
Yes.
I have a question.
Yes.
So the leader node, like, is that the only one? Like, is it just one, so a single point of failure, or could you
Yes.
have multiple leader nodes,
Uh,
like, and load balance it or something like that?
So I think a leader node is more of a logical thing. I think it's not like how to say. There is no separate compute head for that. The compute head or whatever you assign, I think they take it and create a leader node accordingly. Because when you create a compute node, just one compute node, there are no leader nodes. But I think actually there is workload management. So basically, what you'll do is, what is that? Yeah, so you can provide a particular compute node, a particular type of workload. But I think coming to the single point of failure part, so right now the basic concepts in this architecture, one is the client application, which is totally away from the Redshift cluster. Then inside the Redshift cluster, if you have multiple compute nodes, you will have a leader node. If you do not have multiple compute nodes, if you have a single compute node, then you will have no leader nodes because there is only one compute node. And inside compute nodes, you have node slices and they have their own memory and storage. Okay, now coming to the performance of Redshift. So there are 6 factors which they claim to be available in Redshift, which makes Redshift's performance faster, because they told AWS promises that that is 3 times faster than any other cloud data warehouse. So Redshift is the fastest data warehouse available. So you can see these are the options. One is massively parallel processing. Second one is columnar data storage. Third one is data compression. Fourth, query optimizer. Then result caching and compiled code. Okay, so now let us discuss all of these concepts. So first, massively parallel processing. So massively parallel processing enables fast execution of the most complex queries operating on operating on large amounts of data. Multiple compute nodes handle all query processing leading up to a result aggregation, in which each core of each node executing the same compiled query segments on portions of the entire data. So this is what massively parallel processing is, the same thing which was explaining about what leader node does. So basically massively parallel processing enables fast execution of complex queries. But why does it do that? Because it splits it up. As I told you, the leader node splits up the workload, provides it to multiple compute nodes, and the processing is happening parallelly, and all of this results are coupled up together and then provided. So that is what MPP, that is massively parallel processing. And second one is columnar storage. So I think there are two types. One is row based, which happens in traditional databases. The database blocks will have 2 KB to 32 KB, but in Amazon Redshift, a block size can go up to 1 MB, which is more efficient and further reduces the number of input output requests needed to perform any database loading or other operations that are part of query execution. So in Redshift, any data coming in will be automatically taken into a columnar storage. Basically, for example, in a block, normally in a normal database, if in a row-based database, this block will not have only this column's data. So block 1 will have data of this particular row. But in Redshift, block 1 will have it will have the data of this entire column in one block. So basically, if there are 6 columns, then there will just be 6 blocks of which have all the column data in it. So I think for a analytic engine, for example, for Redshift, for a data warehousing tool, columnar storage provides better performance. So you can see here, columnar storage for database tables is an important factor in optimizing analytic query performance because it drastically reduces the overall IO requirements and reduces the amount of data you need to load from disk. So for example, if it is a row-based storage, then for each row there will be one block. So this will basically not take up a lot of storage, but it will take a lot of memory. So basically there will be a lot of blocks. So to take from, for example, if you just want to gather this particular column data, you will not be, so basically you will have to go through all the blocks. Only if you go through all the blocks, then you can get all the data back. But in a data warehousing tool, basic thing is for analytics. So for analytics, you need large amounts of data. You need large amounts of data to analyze something. So let's say you want to calculate the average age. So let's say there are 100,000 records of age. So if you try to do that, if you try to analyze that, then if it is a row-based storage, it will go into every block and gather that particular data, and then it will do the process. But if it is a columnar storage, then it just takes this block. So there will be one single block and it just uses that. So I think this reduces the input output requirements, and also it fastest, so it increases the performance. So as told by Redshift, so Redshift uses columnar storage, and because of that, they're telling it is 3 times faster than using a row-based database for analytics operations. It is 3 times faster. So if it is 3 times faster than a row-based database, basically it requires 3 times less, for example, 1/3 of the memory and the compute capability of a row-based storage used for analytics. So this is where columnar data storage comes in. So this is the basic example they provide. And then data compression. Data compression reduces storage requirements, thereby reducing disk input output, which improves query performance. So data compression, so if you compress the data, it'll reduce storage requirements. So when you execute a query, the compressed data is read into memory, then uncompressed during query execution. So loading less data into memory enables Amazon Redshift to allocate more memory to analyzing the data. So basically for loading data, so if it is compressed, so when that data is loaded into memory, it is not taking up a lot of memory area. So now Redshift can allocate the remaining memory for analyzing that data. So once this compressed data is put inside the memory, then before query execution it is uncompressed, and then that data is used to analyze. So basically this takes lesser memory, so that's why they use data compression. So these are default concepts which they automatically use in Redshift. We don't need to enable these. So these are what they automatically use in Redshift. And then query optimizer, the Amazon Redshift query execution engine incorporates a query optimizer that is massively parallel processing aware and takes advantage of the columnar oriented data storage. So as I told you, Redshift has both massively parallel processing and a columnar data storage. So there is a query execution engine specially designed to take advantage of this columnar data storage and MPP. So there is a separate query optimizer inside Redshift which is running for us, and this is what it does. And then result caching. So to reduce query execution time and improve system performance, Amazon Redshift caches the results of certain types of queries in memory on the leader node. So for example, for let's say multiple people are trying to analyze some particular query data, so they are querying the same thing from the same Redshift cluster again and again. So this query data, Redshift automatically stores it in the cache in the leader node. So once it stores that, then every time it can be taken with it, it can be retrieved faster than going back to the compute nodes, then querying it back, getting it back, then providing the final result. So it also does result caching. So when a user submits a query, Amazon Redshift checks the result cache for the valid or cached copy of the query result. If a match is found in the result cache, Amazon Redshift uses the cached results and does not execute the query. So when you run that query once again, basically it will not run the query. Execution does not happen. So this will improve the performance. So it just takes the result from the cache and gives it back. So the query is not performed. It is not, the workloads are not assigned to the compute nodes. And then compiled code. So the leader node distributes fully optimized compiled code across all of the nodes of the cluster. Compiling the query eliminates the overhead associated with an interpreter and therefore increases the execution speed, especially for complex queries. Okay. So basically the leader node, whenever there is a query coming in, it automatically compiles it first and it gives that compiled code. So I cannot make sense out of it, but this is what it does. So it if you provide a particular set of a query set, so in that there are multiple queries running continuously, so it executes that, executes in the sense it compiles it, it interprets whether there are any errors or whatever, and then it provides it, divides it into multiple workloads and provides it to the compute nodes. So these are the 6 major concepts for improving Redshift performance, and these are already implemented in Redshift. There is no need to trigger them, there is no need to do anything. Yeah. And so workload management or WLM. So flexibly manage priorities within workloads so that short fast running queries won't get stuck in queues behind long running queries. So you can set up, for example, you can see over here concurrency 3, a user group, and so this part we'll see. So 35% memory. So if this particular query is using 35% of memory, then it will be taken up by this queue. If it is taking up 40% of memory, it will take up this queue. I don't know much information about this, so right now I just know this. You can create manual queues also, so you can provide 5% memory, then anything below 5%, and yeah, anything below 5% up till 5% will be in that particular queue, and anything below 35% will be in this queue. Like for example, smaller queries do not need a lot of memory, they occur faster. So for those fast running queries, you do not need to assign a lot of memory. You can just create a manual queue which will automatically execute for us. So if you provide 5%, all the queries under 5% memory usage will be taken care of this queue. And so same thing, you can create multiple queues. And Amazon Redshift WLM creates query queues at runtime according to service classes, so which define the configuration parameters for various types of queues, including internal system queues and user accessible queues. So you can create multiple, I think you can create 50, I do not know the exact number, you can create that. And also there is a queue system implemented inside the Redshift cluster. It is an automatic queue. I think again you'll have to set it up. So there are two types, one is automatic queuing system, one is this manual queuing system. And launching a Redshift cluster, so I launched one, so this will how it will look. And also there are some bugs on the console, I don't know whether in this system, I'll just check that. So now, so this was my cluster name, cluster 1. Then this was the endpoint which they provided. You can use this endpoint to connect with your SQL client. Yeah, so you can do that. Then cluster one, multi-node. Yeah, it was multi-node because I chose 2 nodes and I chose the node type as dc2.large, and I didn't provide any preference. It took US East 1F and created time, yeah, maintenance track, VPC, cluster status, it was available, it was healthy, it was not in maintenance mode, yeah, something like this. So you get also other options. I'll also show that. We'll look into all the concepts in the dashboard. We'll understand that completely. And then querying a database using the query editor, because I'll not be using SQL client, I'll be using the query editor provided by Redshift. And also I have some sample data to load. I also have some sample queries to execute, so I'll be doing that. And then query editor considerations. This, once we complete the demo, then we'll come back here and look at that. And also the query editor allows only these, that is DC.8 into large. This is the previous generation, dc2.large, dc2.8x large. ds2.8x large is allowed, not ds2.large. And then ra3.6x large is allowed. So basically there are 2 node types which is not allowed for using the query editor. So we'll be using dc2.large, so no worries, we'll be able to access the query editor. Yeah, so now let's go to the console. So this is the dashboard, and so there is this bug, guys. So basically, also never, if you're in middle of some process, if you're creating the cluster, if you have typed something, don't click on this X. It goes off, something happens. So if you choose anything, you don't get this part. I don't know why. So yeah. So this is the basic dashboard right now. So launch cluster and query editor, these are the two main services they provide in Redshift. This is for launching a cluster. This is for querying the cluster we created. So these are the two services. And find the best cluster configuration for your needs. So this is a tool they provide. This is a service. So if you want a petabyte scale, then you can choose here and you can choose the number of petabytes you need. So 5 or 1 or 4, so 3, let's say 20 again. So here they provide you a cluster name, they provide you the amount, they also show this. So reserved for 3 years it's $218, reserved for 1 year it is $501.76 per hour. This is not per year, this is per hour. And on demand it is $870 per hour. So this is one tool which you can use for GB 20 GB DC2.large. This is the node type we'll be using today. So for this, if you reserve it for 1 year, then every hour it is $0.32. If you reserve it for 3 years, every hour it's $0.18. So this is actually very economic. If you reserve it for 3 years, if you're using it for 3 years, you can directly launch a cluster from here after choosing it. So like this, you can choose it from here and you can just select it. So for TV, so it gives you recommended options. So you can see recommended DC2.8 into large, DS2.8 into large. So the price also varies. It also shows you the exact amount for the storage which you take up.
Question, is there a maximum storage for the option? Like for example, the large option?
Yeah, I think 1000 petabyte for, so this is the maximum capacity, that is 128 nodes, 2048 TB compressed storage. This compressed storage. So basically you can scale up to 1000 TB here, and then 16 terabytes per node. You'll have 128 node. You'll be provided with 16 TB every node at the start. So I think this is the largest one.
Oh, so as the bar changes, the option changes.
Yeah, option changes.
Okay.
So if I go to GB, it provides me DC2.large. No, there is one more instance. It's not shown here. There is that is the largest instance available. But here, the biggest one is they suggest only this. The largest one is I think RA3.large that I'll show now while launching the cluster. So then you have this cluster snapshots. These are the basic things. So I created one. So there is one parameter group, 3 events. Again, events and event subscriptions. And these are the other options. This is for clusters, query editors. So if you run a query and if you want to save that query, you can save it in saved queries. You can just, there is an option for save. Just hit save, it will be saved here. I think I've saved one query. Yeah, so there is one query. And then snapshot, I've not taken any snapshot. and I've not gone through security. Then workload management, as I told you, they have newly introducing auto WLM. So auto WLM uses machine learning algorithms to actively manage your cluster resources by calculating optimal query concurrency and memory allocation in real time. Auto WLM provides maximum performance for your cluster workload. So to start with auto WLM, choose switch WLM in your WLM configuration. Okay. So I think normally you get this, where is that? Okay, not a parameter group. Workload manager. So workload manager optimizes query performance for allocating clusters to query memories. Yeah, so it creates you can create multiple queues as I told here. So that is what they are depicting. Data coming in. You can manage your workload manager and you can create multiple queues. Okay, so that's fine. I'm not going to go inside that right now. Then reserved nodes. These are as I was showing you, it showed on-demand pricing, then reserved for 1 year and for 3 years. You can purchase reserved nodes here. And yeah, I think Advisor is a tool like recommendation engine for the Aurora cluster. For Aurora cluster, if you create an Aurora cluster, you have an option of recommendations here. If you click on that, AWS, they automatically provide you some recommendations which you can implement or you don't need to. Then events. So you can see creating, where are the events? Yeah, so event 2001, 2000, 1003. So even Redshift has its own different types of events. And I think you can, so this is basically informational. There is no severity. So basically if it failed over, maybe that will create a event and it will provide a severity like a risk or high or something over here. And this is for creation, this is for created, this is for deleted. That's it. And yeah, so this is connect client. So this is for connecting client. You can try these partner tools which they suggest. So I think these are those tools. I don't know, where are they? So I think you can use these tools which they are saying they are partnered, or you can just download the SQL workbench and you can select the JDBC or you can select the ODBC driver and download it from here itself. And so I don't have any clusters right now. So you'll have to choose one, you'll have to choose the cluster and you can download it and you can connect it accordingly. So you get configurations over here. So I'll not be connecting with JDBC or ODBC. I'll be using the query editor. Okay, so now let us start off with clusters. Let us launch a cluster. So again, there are two ways. Either you can go with quick launch or launch cluster. So if I provide quick launch, it is just one page. You can choose the number of nodes here, 1 or 2 or 3 or 4. And you can see if I choose 2.32 TB storage available. So if I provide 4.64, if I provide any number, so it increases accordingly because it's 0.16 per node. And also you are provided with the instances over here, the type of the node types. So dc2.large, dc2.8x large, dc2. So these are the things we discussed. And also they provide the pricing here. Now I think this is better looking than Aurora. They don't provide the pricing for the instance classes, and the storage they've provided per node. For dc2.large, it's 0.16 per TB per node. This is 2.56 per node, 2 TB per node, 16 TB per node. So these are dense storage engines. These are dense compute engines. So these are for compute. So they have lesser storage, and so accordingly, if they have lesser storage, it is an optimal. They have optimal memory. And here the storage is very high. You can store a lot of data in these two node types. You can choose them from here, and after that you'll have to provide a name, then provide a database name and provide the port number. This is the default, it automatically takes it. And then master username, you'll have to provide the passwords. And if you are going to use any other service, so for example, I'm going to show you how to load from S3. So you'll have to choose one of the roles. I'll also show what kind of a role to create. So first let us create the cluster and then we'll move on to that part. So either you can use the quick launch or you can go to the advanced settings. Again, if you have typed something, if you close this, then this particular page goes off. So okay, Then yeah, I'll just shift to advanced settings. So here you'll have to configure one by one. First, you'll have to provide the cluster details. Then you'll have to provide the node configuration. Then some additional configurations like I think security groups or something. Okay, so now first cluster identifier. I'll provide cluster one. I don't have a cluster. Then the database name. So optional. This is optional. This is not mandatory. You can see there is no star here. A default database named dev is created for the cluster. Optionally specify a custom database, example MyDB, to create an additional database. So a database is already created when you normally create a cluster. If you want an additional database before launching the cluster, then you can provide the name over here. And then after creating the cluster, you can create any number of databases inside that. So I'll provide a name. Let's say so dev. So I'll just create one. Let's say test. Database name test. So I'll just give test one. I don't know whether there is a test already inside. Okay. So cluster one, test one. Port number is 5439. Master user. I'll just go with admin. For password, admin 123. But I think you'll have to provide a combination. So it has to have one uppercase letter and also one number. So they provided that here. So I'm just going to make my A capital. So still it's admin 123. So done. So now continue. Now here you'll have to choose the node type. So here you can see in quick launch you did not see this node type, or you only saw dc2.large, dc2.8x large, ds2.large, ds2.8x large. These two are the previous generation node types, and this is the newest one. Yeah, so I'm just going to go with dc2.large. And again, you also choose dc2.large. And here 7 EC2 compute units, 2 virtual cores. So per node, it provides 7 different compute units. As I told you, there will be node slices. So these are them. So there will be, I think, 7 node slices accordingly. And then memory, 15.25 gigabyte per node. That is, I think, yeah. So 15.25 gigabyte per node, and then 160 GB SSD storage per node. Yeah, moderate. And then it can be either single node. There is one option, one, or multi-node. The maximum number of nodes you can provide for a DC2 dot large instance type is 32. So I'll just go with 2. I don't want a huge instance right now, so 2 is fine. So next, you can also read this. So compute nodes store your data and execute your queries. In addition to your compute nodes, a leader node will be added to your cluster free of charge. The leader node is the access point for the ODBC/JDBC and generates the query plans executed on the compute node. So also one of you asked whether leader node is only one. Is that might be a single point of failure. That also we'll look into right now. Then continue. So default Redshift, there is one parameter group already existing. It automatically took that. As I told you, a parameter group would be a set of flags. They'll all be flags. You'll just have to provide the value. So it automatically takes a default one. If you want to create your own one, you can. Yeah, you can create your, you can edit this, I think. And then database encryption, you can either go with none. You don't need, right now I do not need, but you can go with KMS. They encrypt it with their own default key, which is available in AWS. You don't need to do anything. It is encrypted for this particular account, which is my account. So I'll just go with none right now. And then VPC default is automatically taken. Availability zone, you can provide one, or you can just provide no preference. It automatically takes one. And then cluster subnet group default, again, because I chose the default VPC, and the default VPC has a default subnet group, it is automatically taken. Publicly accessible, yes, it should be publicly accessible. Only then I'll be able to connect with SQL client. And then choose a public IP address. So here, what does they mean is they provide an elastic IP address for this. So if I click yes, you can, if you already have an elastic IP available in your AWS console, you can choose. If you do not have, just provide no. They'll create one automatically and they'll assign it to the Redshift cluster. And then enhanced VPC routing. So basically, if you click on enhanced VPC routing, all the queries, all the data going in and out will go through only all the data coming in or going out will go through one particular VPC. So you'll have to do more configurations for that. You'll have to create a VPC which does not allow data to go out. It should not be publicly accessible and all that. So that's what VPC routing basically means. And then list of VPC security groups to associate with this cluster. Associate your cluster with one or more security groups. So this, I think you cannot select anything. It automatically picks it up, but you don't need to provide anything because as I've chosen default VPC, it automatically takes my default security group. It does not take any other security group. If you provide another VPC, if that VPC is combined with a particular security group, then yes, you can, that will automatically be taken. But right now, where is default? Yeah, so this will be automatically taken for me because that is my default security group. And then you can create a CloudWatch alarm directly from here. You can choose. So these are the only options provided in this console. That is 70 till 95, and use existing topic. So you guys all know what is a topic. It is basically used to send email notifications, and use existing topic in the sense you'll have to choose one, and that's it. You can create one from here. So disk usage threshold at which the alarm will trigger when disk usage across all nodes reaches this percentage. So when the disk usage in all nodes are going to reach 80%, then this alarm will send an email to this particular topic. So I don't need a alarm right now. And then maintenance track current, trailing, and private beta. So if you choose private beta, you can basically preview the features, but you cannot. So I think don't choose this. Either choose current or choose trailing. So current, select current to apply the latest certified maintenance release, which includes the latest features and the latest bug fixes. If you choose trailing, it applies the previous, that is the previous certified maintenance release, the one before this. So that is what trailing, and this was current. You can just go with current for the latest. So if you want to attach a IAM role right now, you can just directly go. I already have one. I can attach this, or I can attach it later. So I'll attach that later. So right now, let us launch this cluster. So these are the, we've provided all the configurations. That is more than enough. And now, unless you are eligible for free trial, you will start incurring charges as soon as your cluster is active. So as I told you, if you have not launched, so where is that? I'll take you and show it. I just want to make you sure. So try Amazon Redshift for 2 months free. If your organization has never created an Amazon Redshift cluster, organization in the sense your AWS account, if you have never created a Redshift cluster in your AWS account, you are eligible for a 2-month free trial of our DC2.large node. Yeah, you get 750 hours per month, enough for us to continuously run one DC2 large node with 160 GB. So this basically 750 hours per month is for one node. So if you run 2 nodes, that hours will be divided between those 2 nodes. If you run 3, it will be divided between those 3, 4 accordingly. So it goes on up till 32. So if you run 32 nodes for DC2.large, then that 750 hours will get it'll get over soon. So 750 divided by 32, that's it. Yeah, so that's it. So what else? Who's eligible? So you are eligible for the free trial if your organization has not created an Amazon Redshift cluster since July 1st 2014. So if you have not created a cluster since 2014 July 1st, then you are eligible for this free trial program. Yeah, so I think most of you would have not created a cluster, so I think yeah, you'll be eligible for this free trial. Yeah, so others are the same, they state the same fact. I just wanted to show that. And yep, so if you do not have free trial, if somebody does not have a free trial, then the on-demand hourly rate for this cluster will be $0.5 or $0.25 per node. So for this, there are 2 nodes, so plus a free leader node. So for the leader node, you don't pay anything. And $0.25 if you have purchased reserved nodes in this region for this node type that are active, your costs will be discounted. So basically, if you have bought a reserved node from here, so then in this region, so in North Virginia region, if you have bought a node, then that particular node's charges will be discounted accordingly. and then there is no charge for the leader node. If you're eligible for free trial, it's the same thing. So I'll just launch the cluster. So now let us view all the clusters. I think it would have been created. Is it still creating? Yeah, it's still creating. So once it creates, we'll be able to see inside that. We'll be able to see the endpoints and stuff. Let's wait until it gets created. So I think it's available right now. So the cluster is available right now. So 3 events happened. Created, deleted, created. Oh, this was back. So right now it's created. Okay. Okay, right now the cluster state is available. The DB health is still unknown. It'll check for the DB health and tell us. It'll also give us the detail whether it is in maintenance or not. So it'll tell it's in maintenance or it'll provide not in maintenance or something like that. And then coming down. So right now they have provided an endpoint. So yeah, so you'll have to use this endpoint to connect with your SQL client. And then cluster properties, you have the name, it's multi-node, node type 2. It got created in 1F, the time and everything, the cluster version, it's up to date, the latest version. That's what I told, because if you use maintenance track current, the latest latest release will be used. And then VPC, then cluster subnet group, VPC parameter group. So I don't have any IAM groups till now. Cluster state is available, so database health is also provided right now. It's healthy. It's not in maintenance mode. Okay, fine. So now database properties. The port number is 5439. It is publicly accessible. We created a database name called created a database called test1, and then we created master username admin. It's not encrypted. So they've provided for both. So basically JDBC Redshift colon the endpoint with the database name. For ODBC, it's driver, server name, database test1, UID admin, password. You'll have to enter the master password and port number. So this is the URL for JDBC and ODBC. And then yeah, so this is backup, audit logging, and maintenance. A low version upgrade, yes, yeah, okay. And here comes capacity details. DC2.large. Then we have total of 7 easy to compute units. That is 2 virtual CPUs per node. So according to that, there are 7 easy to compute units totally, and 15.25 gigabytes per node, 160 GB SSD storage per node, moderate 64 MB. And this is the public key of the cluster. I think we can use this for SSH, so logging in with that. Then they've provided the node IP addresses. So the leader node's IP address and private IP is this. The compute nodes public, and this is compute 0, compute 1. So you can have up to compute 32. Sorry, I think it'll be 31. Yeah, compute 0, 1, compute 1. So yeah, so public IP, and private IPs of these created nodes. So now, as one of you asked, what will happen if there is a failure of the leader node? That will check. We'll go to the FAQ of Amazon Redshift. In case of node failures, Amazon Redshift automatically provisions new nodes and begins restoring data from other drives within the cluster or from Amazon S3. It prioritizes restoring your most frequently queried data on your most frequently executed queries will become performant quickly. Okay, so now let's just check this. This is more informative than just reading that metadata. So I think over here, availability and durability. So what happens to my data warehouse cluster availability and data durability if a drive on one of my node fails? So this does not answer it. Yeah, so this is individual node failure. So individual node failure in the sense, Amazon Redshift will automatically detect and replace a failed node in your data warehouse cluster. So this is automatically done. If there is a failure so for example, we have 2 nodes. The node has been there is a node failure. So yeah, it will be replaced. The data warehouse cluster will be unavailable for queries. So that particular node, if one node fails, it will be unavailable for queries and updates until a replacement node is provisioned. So your entire warehouse is unavailable when there is a node failure occurring. and is provisioned and then added to the database. Amazon Redshift makes your replacement node available immediately and loads your most frequently accessed data from S3. So the most data, the data which is frequently accessed, that data will be taken and first stored, and later all the data is loaded back. Single node clusters do not support data replication. In the event of drive failure, you will need to restore the cluster from a snapshot on S3. We recommend using at least 2 nodes for protection. So yeah, so this is at least they are telling us to use 2 nodes. So if even I think this is just for one node. So if one node fails, event of individual node failure, then your cluster will not be available. So if you have 2 nodes, if one node fails, at least that one node will be working. And then this is for the entire availability zone has an outage. So if your Amazon Redshift data warehouse cluster, the entire availability zone is having an outage, if it is completely unavailable, so you will not be able to use your cluster until power and network access is restored to that availability zone. So yeah, your database data warehouse clusters data is preserved so that you can use you can start using your Amazon Redshift data warehouse as soon as the availability zone is available. So the data is preserved, the data is not lost. If when the availability zone comes back up online, then that data again, new one is created, or already the existing cluster is provided, will be available right now, so you can start using it. And in addition, you can also choose to restore any existing snapshots. Yeah, so if you created any snapshot, you can use that to create one more cluster, and Amazon Redshift will restore your most frequently accessed data first, so you can resume queries as quickly as possible. So I think yeah, so they have not provided. Yeah, it's over here. You will not be charged, only compute nodes will incur charges. You'll be billed for okay. How do I load data inside? Okay, we have the single leader node. Nowhere they have provided that. Can I access compute nodes directly? No. Your Redshift compute nodes are in a private network space and can only be accessed from your data warehouses clusters leader node. This provides an additional layer of security. I think there is no other go. You'll have to use leader node. So I think even if there is a failure, they'll provide a new one immediately. There is no other strategy. Either you can have another cluster. So after that, like when your cluster, one of the cluster goes down, you can have another cluster in another region and just use that until this availability zone comes up. So I think there is no part of having like there is a leader node failure or something. So even if the cluster endpoint is not available, then I think you'll have to wait until it comes back up. That's the only chance here. But if the node goes down, then if you have 2 nodes, one node will be working. If until the other node comes down, this node will be used. If you have multiple nodes, then it's better. If you have a single node, if the node goes down, then yes, your entire cluster will be down. No queries or nothing can be, nothing will be running. Any queries coming in will be cancelled. Any client connection will be cancelled. So yeah, so that's what. If there is a case of leader node failure, so you cannot do anything else until you can just wait until it comes back up. That's it. So yeah, so right now we have created a cluster. Okay, so coming back here. Okay, so we have created a cluster, guys. So that's it. It's you'll have to provide the information and that's it. So now we have a database named as test1. So I'll show how to connect this database from your query editor. So now I'll open query. I'll open query editor over here. So when you click on query editor, it shows this. So this was with the previous cluster. It's still trying. So now I'll just close this. So cluster one is the cluster name which I have right now. So the supported nodes for query editor are these 4: DC1.8x large, DC2.large, DC2.8x large, DS2.8x large. DS2.large is not you cannot use that particular node type in query editor. And then you can also use the RA3 node type. You can also use that. It's not provided here, but as I read the documentation, it was provided there. It is in the PowerPoint also. So yeah. So now to log into this database, it's pretty simple. Enter the database name. So you can enter the database name either dev or test1. So test1 dev is already created. Test1 is the database we created while creating the cluster. So now hit test1, provide the database name, database username. I have only admin, and then password and connect. So now it is connected. That's it. So I think here you can see the viable databases, or yeah. So this is the console. This is how it looks. Provides the cluster name. It provides the database name. So here, yeah. So if you click on the database, name, you will be shown the available databases. So you have dev here. You have another database. I don't know what is this. So you have these three databases here right now, and you can shift if you click dev, and if you hit connect, you'll be connected with dev, and you can do that accordingly. So now I'll close. So here you can type in a query and run that query. So let's create a database here. Create database, say dev2, and run the query. So query completed in 0.861 seconds. Statement completed successfully. A statement completed. Yeah. So right now, so I think I'll have to wait for some time. Or so we've created the database dev2, but why is it not available? Let me check once again. Yeah, so now it is available. Dev2, we've created a database. So this is how this is how simple it is used query editor over here. So that's it. So now guys, now let us do a simple demo. That is, I'll create a role. I'll attach it to this Redshift cluster. So what that role basically does is it provides the permissions to access S3 for this particular Redshift cluster. So once I provide this, from this Redshift cluster, we can query data which is stored in S3. So I've already stored some data in S3, and I'll also show from where to get that sample data. There is a tutorial I followed, which is AWS. Again, I just follow AWS official white papers and documentations. So from there, you can get the sample data and you can upload it to an S3 bucket. From there, you can provide the IAM role to this particular Redshift cluster. After providing it, you can just query it and create tables here. After creating tables, load data into this database. After loading data, you can query the data stored. So yeah, so let us start with that. So for that, first I'll have to you open IAM. So first I'll have to create a role. As I told you, I'll have to create a role. So role, create role. The service which I have to provide the permissions to is Redshift. I'll have to choose Redshift. Redshift is over here. So I'll be choosing Redshift customizable. There is one thing called scheduler, and this is not for clusters. This is for clusters. So I'll just choose this. And then here you'll have to provide the permissions for Redshift accessing S3. So Redshift does not need any other access. It just needs the access to read objects inside S3. So let's see. Yeah, so here S3 read. So there is this, that is Amazon S3 read only access. So this will allow the Redshift cluster to only read the data from S3. So I'll just click here. Next, tags. If you want, you can add a tag. Let's say name Redshift. Then review, provide a name. Allow Redshift to S3. And yeah, so this allows Redshift clusters to call AWS services on your behalf, and then create role. So the role, yeah, so the role is created. So I'll just copy this. We will need this ARN ahead in this demo. So I'll just copy this. So this is one. I'll just open another, save it here. Okay, so now we've created this. So we are going to attach this role to our Redshift cluster. So I'll go to my cluster. I think I can manage here itself. Manage IAM roles. Choose a role. This is the role I created right now. That is allow Redshift to S3. Click on it and then apply changes. Yeah, so now it's modifying. So we have attached a IAM role to our cluster. So that part is done. So the next part, because we are going to take in data from S3, so now data should be available in S3. So I'll open the S3 console. So I've already uploaded the files inside S3. I'll show which bucket. Yeah, so it is Amazon Aurora bucket, the bucket which I created long back. And I've created a folder inside that data. And inside that, all the text files are available. So those text files, I have the zip file of that, and I'll also show which documentation to go for, like which documentation you can go through and get the, what is it? You can get the load this particular files, the zip file, and also from where you can get the queries. So yeah, so right now we have attached it to the cluster. Also, we have the data inside our S3 database. So it is over here. Yeah. So I created a folder, uploaded the data into it. So right now my S3 is set, data is ready. Now I just have to run the queries accordingly to uh, create tables. After creating tables, I'll have to load that data inside those tables. That will be my second part. After loading data inside that table, after that I'll have to start querying. So right now, I'll just show that. So first, I'll be creating these tables. After creating these tables, I'll be copying. So these are some more queries. So you would have taught why I copied the ARN. So basically, I'll have to copy this ARN and paste it here. So this will show. So basically, the query editor does not have access. So for that, we'll have to provide this so that the S3 bucket knows that. So this particular, how is it, IAM role. So basically it allows the Redshift cluster to access the data from S3. So while providing this ARN, the S3 bucket will automatically understand we can provide the data to it. So this is that. I'll also paste these in the end. And then these are some sample queries which was available. So yeah, so done. So now let us start off with this process. So first I'll go to my query editor and then I'll just do this and do this. Yeah. So now I have my query editor and here you can see the query results. So now, yeah. So now first we'll have to create tables. So first I'll create this table, run query. So completed in 0.8 seconds. So done. I've created one table and now I'll load the data for that particular table. So now I'll just copy this. I can just paste it in this query and hit run, or I can create a new one and hit run. So I'll just run here. What is this? Oh, sorry. I did not change the role.
What's the copy user?
So these are some for query editors. These are the commands for copying users in the sense
Oh, the table name.
users. Yeah.
Okay, got it. Yeah,
Yeah.
confused with the user
Yeah.
ID. Okay.
Okay. So now I forgot to change my ARN, that is Amazon resource number of my IAM role, which I just attached to my uh, Redshift cluster. So I'll just paste it all over in my queries. Yeah, so that's done. Okay, so now I think it'll work. So yeah, it's the query has run successfully. So now we can just use this one query to do all the operations, or we can open another query and do. So we can do this. So as a best practice in the documentation, they told run one query in one query page. So one complete query in one query page. That's, I don't know why, but that is what they have told. Sometimes when you run multiple queries, there are some errors occurring here. It's showing some kind of indentation errors or something. So that's what it was showing here. So run one query at a time. Then, but you can run a query in the same query dashboard multiple times. So I'll just upload the content of this. Done. Then category. So just wait, I'll just finish this off. I'll just create multiple queries, paste, run. And then date. Successful. Done. Event. So done. Then there are two more. Listing. And then sales. Just create one more. So every time you open, it shows the results. It's taking some time to show. Okay, so we've uploaded all the content inside our tables, but one more thing is you'll not be able to view that content here. That is the only problem. It is just to query. In query editor, you'll not be able to view the data you stored. So for that, you'll have to use an SQL client, but you'll be able to run queries and then see the data. So yeah, that you can do. But there is no option for viewing all the tables available like that. So you will just have to query all of them and see here. Yeah, so if it is a client or a workbench or something like that, you have everything. You have your own GUI, which you can use to see the tables available or the database is available and everything. But in the query editor, you can only query. That's the only option here. So now we have uploaded the content. So I'll also show what was in the content. So where was it? Think the name of it was ticket. Yeah. So these are the files. They're all text files. So here you can see. Just a second, it's loading up. So this is how the content was available. So you can see the number, code or something, whatever is that, name, middle name, last name. So whatever order, and then the email, the number, some questions, true, true, false, true, true, false, true, something. Okay, so you can see there's a lot of data available. So these many queries, sorry, these many rows. So basically, it will not be uploaded as single rows. So if it is uploaded as single rows, every time it will take a lot of time. So what they do is they consider this entire column as one row, one. So they do that and they upload it. So basically it happens in Redshift and it happens transparently, which that's what Redshift promises us. They use columnar data storage. So I just wanted to show this. Also, I'll give the link for downloading this sample data, which you can use for practicing. Yeah. So now we have uploaded all the content. We have loaded the content from S3 into Redshift. So now we'll just do some querying and practice it. So sample query is, so this one is to get the table definition, I think. Table definition of table name sales. Just push it up. Yeah, so table definition over here. So you can see the query results over here, and also you can download the CSV file from here and just save, and you can download it, and you can also view the results here. Okay, so there is some problem with this. So you can also download the CSV file and view it, and that's it. And then another query, select sum this from sales date where sales.dateid is equal to date.dateid. So they are just doing that and calculating on the date, on this date, they're calculating the sum of quantity sold. So now when I run this query, I should get a number of sum. So yes, so we've got that number. So that is the only result we get because that is the only result we needed. So this is one query, and then there is this. So here they've provided the limit as 10. Okay, so we'll get 10 rows of output. So showing rows 1 to 10. So you can see first name, last name, total quantity. They have provided the name and last name and the total quantity. So that's what mentioned here. Select buyer ID, sum quantity sold, total quantity from sales, group by buyer ID, order by total quantity, limit. So we'll just change this limit to 200. I could have just changed here. So they provided 100 rows here and then another 100 rows in the next column. So I think 100 rows is the limit for one particular result column, and you can also download this entire CSV file and just look at the results for yourself. Okay, so they have provided it here completely. Yeah. So yeah, this is one query. I'm just doing some sample queries to show how it works. So then select, and again another query, same thing. So here, so that you can see the query results are faster, even though there is not a lot of data, but still we can consider. But when there is really a large amounts of data and you want to query some results, they happen very fast, because as I told you, that's how Redshift has been architectured. It has one leader node and multiple compute nodes, which distributes the workload, and accordingly complex queries are divided into simpler queries, and they are executed, and the results are clubbed in leader node, and that final aggregation is sent to the client tools. So yeah, so we've done query editor also. And one more one question about IAM database authentication. And so I tried. So basically, instead of, you'll not be able to assign roles to your on-prem setup, but you can use secret and secret access key and your access key to authenticate. For that particular IAM users, you can provide programmatic access, and those users can use their secret and access keys to enable IAM database authentication. But you can only use that for RDS instances, RDS databases, because only there you will be able to enable it. After that, you can just use that endpoint, and yeah, you can use the security credentials to log in, but you'll not be able to use IAM database authentication on your server, but you'll be able to use, what is that, your secret access key and also the token, and do that. So that is the only option. Okay, so now coming back here, so saved query. So coming back to the query editor, I forgot to show one thing. So for example, if you think you'll run this query often, so you can just save it here. You can just save it here, provide a query name. Let's say this is, I don't even know what query is this. So I'll just give query 1, and again query 1, add query. So done, query is saved. Yeah, so it's over here. So now go to saved queries. So this is saved query. Download entire SQL text. So you can download this query's SQL text, or you can copy the entire SQL text and just if I just paste it here, so we'll get it. So this is pretty easy. You can just save your queries over here and get them whenever you need. So also this is easy to control. You can just search what query you need accordingly and get it. And then yeah, so this is pretty much saved queries. That's it.
Okay guys, we've come to the end of this session. I hope this session on Amazon Redshift was helpful and informative for you. If you have any queries regarding this session, please leave a comment below and we'll love to help you out. Thank you.